So we're in 5.2a. This section is called Multiplication and Division of Rational Expressions. Now, if you thought that last section, 5.1, was difficult, you will be so glad to know that this section is a lot easier. Not going to say it's easy, but I'm going to say it's a lot easier. So first of all, this should help because there are no letters here. So this is multiplying rational expressions and dividing rational expressions. So if you remember when you're multiplying, some of you are quick enough to just be able to cancel this and put a 1, this, and a 3. This a 1 and this a 2, and you end up with 2/3. That was pretty quick and easy, but they aren't all that quick and easy. So one of the things that you learn to do over the years is take the prime factors of each of these and then you can go through and cancel 2, 2, 3, 3, 7, 7, and you're left with 2/3. So prime factors of each of these terms, and then you just cancel like terms, and you're good to go there. So let's look at it. Look at example 2 using that idea here. So 8x cubed over 27x, y to the 8th times 9y cubed over 12x squared. Okay, let's find the prime factors of each of these. And once you get better at it, it's really not, you may not even have to do all of it. I'm going to leave my letters the way they are. So let's cancel numbers. That 2 with that 2. Okay, that with that, that with that. So that's going to leave me 2 on top and 9 on bottom. Okay, now let's see what else we have. We have a 3 here and an 8 here. So we have 5 down here once we cancel all three of these with 3 of these 8. And we have 3 x's and 2. So we're, instead of 3 x's and 2 x's, we have 1 left over up here. Or if you do it the way we did it earlier, let's just go ahead and do that. Whenever you're dividing, like x cubed over x squared, which is what we have here in here, it's x to the 3 minus 2, which is x to the first, or just x. So that's where we got that x up there. I realize I'm going kind of fast, but hopefully that's just review for you, and you should be able to cruise through that pretty quickly. All right, so let's look at example 3. Example 3 says x minus 3 over x squared minus 4 times okay, notice my numerators here cannot be reduced anymore. They cannot be simplified. They're as simple as we can go. So we're going to ignore those. But we do see that this is a difference of 2 squares, and that can be written as x plus 2 times x minus 2. And this we can also write as x minus 3 times x minus 3 when we factor it into our two binomials. So let's go ahead. Okay, then we just start canceling there and there and there and there. And we're left with an x minus 2 and an x minus 3 on the bottom. And everything is going on top, so there's always an assumed 1 up there. Okay, let's look at example 4. Okay, so we're going to look at one bit at a time. We're going to look at this. We're going to reduce this, this, and this, and then we'll work at canceling. So our top one, we're going to change that to 2y times y minus 2. And that's going to be over 2 times y squared minus 1 times, divide this into two binomials, a y, we've got a 3, and a 1 plus minus, and then we've got this here, that's also going to break into two binomials, a y, and we'll do a 3 and a 2, both of them minuses. Okay, only thing we have left to do is that is the difference of two squares, so that can be written as, so we're going to replace that with y plus 1, y minus 1. Okay, don't forget to do that. Always look in at your exponents, and if there's an exponent of 2, you most likely are going to be able to reduce. All right, so let's go ahead and see what we can do as far as getting rid of things. That one, that one. Okay, is there anything else I can reduce? Oh, the 2 here and the 2 there. So that leaves me with a y and a y minus 1. So when I multiply this whole mess out, I get something as simple as that. All right, let's look at example 5. And we'll do that on 5.2b since we're changing directions and we're going to start doing some division.